In the previous lecture, we started the EC2 server, which was named as Course ETH Node 1, and logged into the server using the SSH command. As you can see right now, we are logged into the server and ready to execute any command. Before we proceed, we need to install the Go Ethereum client, which is the Ethereum client for Ethereum blockchain. For installing the client, just copy these commands one by one and paste them here. So copy the first command and paste it into Install Software Properties Common. Copy and paste the second command to add Ethereum repository. Then, copy and paste the third command to update package lists. It might show 404 for some of the packages. You may ignore that. It may happen or it may not happen in your server, depending on package list. Next, copy and paste the fourth command. This will lead to the installation of the Ethereum. Remember, if you are using any other server, you need to enter the commands accordingly. Please refer to ethereum.org/CLI for more instructions on that. For asking yes or no to continue the installation, type yes. While the installation process is in running state, let's open ethereum.org/CLI. You will see all instructions or installation commands based on the operating system and softwares. So you can use GETH if you are installing on Mac. You can use this for installing on Windows. If you're installing on Linux like Ubuntu, you can use this. So, there are multiple clients. We are using the Go Ethereum clients, which is a Go implementation called Geth. So it will take some time to install the Go Ethereum. After installing the Go Ethereum, we need to make sure that servers have this running. Remember, we can have one or more server like this, or currently I am just setting up everything in one server. I will launch another server soon. The notable point about this is you can take the template of this server after this step. Till this step, take the image of the server, keep it there and launch whenever you want to launch, so that you don't have to install the Go Ethereum client again and again. When you take the AMI, or the template of the server, it will take a template till this point. So as you can see, this Go Ethereum has been installed. At this point, you can take the template and then you can launch multiple servers of the same template. We haven't done anything specific to this server as of now. So, to check whether this has been installed or not, you need to type this command, geth-help. It should not be doing this. It has actually started launching the server. It should be showing some help message. Type geth-help. You will have to type double hyphen or single hyphen H for help. If you double type hyphen or single type hyphen, you will see the message like this. The message like this is an indication that your Geth client has been installed properly. In the next lecture, we will be installing and configuring the nodes. Let's try to launch the Ethereum node in this lecture only. Let's perform step 3. Go to the terminal. Type cd command to go to the home directory. Next, type pwd command to know the present working directory. So, our present working directory is listed out. Now, we will create a new directory by typing the command mkdir eth-dev. eth-dev stands for Ethereum Development. To move into this directory, type the command cd eth-dev. We are currently in this directory. Here, we need to create a Genesis block. Remember, to create a private blockchain in Ethereum, you need to define the Genesis block manually. Usually, the Genesis block is actually embedded inside the client, but Ethereum allows you to define the Genesis block in the blockchain using the JSON objects. So, to create a Genesis block, type the command nano-genesis.json. Copy-paste this JSON object. So type the command nano-genesis.json and press Enter. Now paste JSON object here. So, I'll explain. This is the Coinbase. It is the default Coinbase address. If you do not have any Coinbase address or haven't created any new wallet yet, you can put 00 over there. This difficulty attribute defines how difficult it is for a miner to create a new block. You can provide extra data with extra data attributes. Gas limit is the limit required to execute a transaction or send the Ether from one wallet to another. Nonce is the random number for this block. This is the random number which every miner has to guess to create a new block. Since this is first block, you need to define or hard code it. Here, we have taken hexadecimal 42 as nonce, though it can be anything technically. The mix hash attribute is the number which is required for Genesis block. The parent hash attribute is the hash of the parent block. As there's no parent block, so the value is 0. Timestamp is a timestamp defined for the Genesis block, which can be empty or 0. The alloc attribute specifies the number of pre-mined coins or ethers allocated to a certain address. We don't want to allocate, so we will keep it empty. The next thing to do is to execute the command Ctrl+X and type yes to save the changes and press enter. If we list directory contents, we can notice that genesis.json file is created. To view its content, type the command cat_genesis.json. This displays the entire JSON content. So, we have completed the Genesis block JSON file. Next, we will initialize the chain data using the command geth -data dir ~eth-dev/init genesis.json. Here, geth-data dir is used to point to data directory. ~/eth-dev, where the chain data is initialized. Init genesis.json initializes the chain data using genesis.json object. Instead of creating a fresh block, it will use the genesis.json to create the first block. Note, on executing this command, if you see successfully wrote Genesis block, it means the command is successful, else there is some error. You can see in the last line, it says successfully wrote Genesis block and or chain rule set. Now, on typing the listing command ll to the list of files and folders, you'll see the geth folder and the keystore folder created using the init command. Next, you need to go to the geth folder by typing cd geth and then ll to view its content. You can see chain data there. Move the chain data by typing cd chain data and then ll. You may see the list of meta information, which you don't need to understand at this stage. So, the chain data is initialized. Next step is to shoot the Ethereum server. To do the same, copy the entire command, but please note since it is in the PDF format, thus it includes line break. So copy and paste the command line by line. Let's copy and paste the whole command in editor and remove line breaks. Let me explain parameters of this command. Data dir ~/eth-dev/ indicates the data directory used by the geth client. Network ID specifies a random number, which should be as random as it can be in case a private network is used. Verbosity 3 specifies the log level. Here the value is 3. We'll change it to 4 to view more information. IPC disable specifies that the IPC protocol is disabled. RPC attribute specifies that the RPC, remote procedure call, needs to be enabled. Port 3301 specifies the port number on which Ethereum should start. 3301 is the default RPC port. RPC port 8545 specifies on which RPC protocol should start. 8545 being the default RPC port. RPC ADDR specifies the public DNS address of Node 1 where you want this RPC to be accessed. This address can be a public IP address or DNS address. Remember, in EC2 console, you can see public DNS address and IPv4 public IP address at the bottom right corner. We can use either of the two. But AWS has some problems in accessing this IP address inside the server. We'll copy the public DNS address and we'll replace the value of RPC-ADDR attribute with the copied address. Console is the attribute which shows you the console or a JavaScript console for the Go Ethereum client that can be used for typing the commands. 2 ~/eth-dev/eth.log indicates that you are appending all standard output into the eth.log file. You're putting all the logs into this file while accessing the console separately. Copy the command and paste it. We'll see the Geth console. Now, if you wish to see the log content, open the new tab, SSH, into the machine again by typing ssh-i ethereum.pem ubuntu at public IP. Copy the IP from the EC2 window. Both the tabs are connected to the same server. Now, to check the log, use the tail commands tail-f tilde/eth-dev/eth.log. So as you can see, the whole log is created. The HTTP endpoint is opened. RPC endpoint is opened at this address. Let's copy this and try to open it in the browser and see what will happen. Security group needs to open this port number. Let's open the port number. We have not opened any inbound as of now. So to open certain ports, click Edit and enter the port number to be opened. Here, it is 8545, and this port needs to be opened at any address for which we've selected 0.0.0.0. We also need to open the port where the Ethereum is running. Remember which port we have used. 3301. We need to put the range. We'll put 00 to 999. We opened all the 100 ports. And here also, let's open 100 ports. Let's say 8500 to 8599. We opened all 100 ports of the series. And then you see if you can see the data. We are seeing some JSON RPC response. This means JSON RPC has been opened successfully. We can run commands here and see the logs here in the next screen. So for the sake of creating a new account, type personal.newaccount, brackets, and password 12345678990, and then enter. As you can see, new wallet appeared and key store has been stored properly. And this is our Coinbase account. We need to copy this account to keep it separate so that we don't have to look into this again and again. Let's put this here. Let's call it Coinbase. We need to save this file. So we have just installed and configured the Ethereum node and accessed the JSON RPC on this folder, and also logged in and saw logs using tail command. So that's it for this lecture. In the next step, we need to do the same for node 2 and then see how it works and start with the mining. Thank you.